Okay, so there was a game posted on Reddit on our math. It's a pretty simple game. Um, you just create a warrior, which fights other warriors with simple rules. The warrior has stats: physical attack, physical defense, special defense, magical defense, and speed. And the stats are a lot like Pokemon stats, if you think about it. But the stats have to add up to 100, so you can distribute the stats however you want from 0 to 100 in each stat, but the sum has to be 100. Um, and then the way they fight is on a physical round. They do physical damage based on their attack times a percent based on the defending warrior's defense. And it's the same thing on a magical round. Speed determines who attacks first in a round, so it acts as a tiebreaker if they both would kill each other on a certain round. And that's all there is to the duels. Now, this is probably ignoring some of the game theory stuff if you wanted to seriously consider who would win. But one way to try and come up with a good candidate for like how you're going to distribute your stats, at least an interesting way, is a genetic algorithm. By mimicking sort of the evolutionary process, we can try and almost evolve an ideal warrior who obviously won't win every round, but maybe will be set up to win as many rounds as possible. And so this algorithm is sort of going to be divided into three parts. Um, there's a gene pool that will be mutated into a generation of warriors. The warriors will fight each other, and then based on that fighting step, um, they'll produce a new generation of warriors in that like gene pool, and their the warriors' uh, success in the fighting step determines how much they pass on to the gene pool. So, like, if a warrior um, wins all of its battles, it's very likely that its genes will be used for the next warriors. Whereas if a warrior loses all its battles, it's not as likely. It's probably less not going to happen actually. Anyway, so going in depth into the steps. First of all, we just have the number of warriors, the number of iterations, which is like generations, and the maximum mutation. Um, I'll explain what the max mutation affects later, but the warrior number is just like the size of the population of each generation, and this is the number of generations. And so when we start this, we just want to give them each like 20 for each stat. It doesn't matter. It could actually be interesting to see how it affects it. But in any case, this is something interesting, sort of related. Each warrior has to fight every other warrior, and so the number of fights that is actually the handshake problem. If you have a bunch of people in a room and they have to shake everybody else's hand, how many handshakes is that? And I won't spoil that, but it's pretty cool. It's also the number of edges in a complete graph. Um, anyway, yeah, but that stuff is also interesting. There's other stuff to get to though. Um, for the mutation step, um, for each of the warriors in this array of warriors, we're going to give them some random mutations. This is where the maximum mutation comes into play. So what these two for loops do is the J is the first stat that we're going to add to, and then the K is the second stat that we're going to reduce. And remember, whenever we add to one stat, we have to subtract that from another stat, which is why there's the J and the K, because the stats have to still add up to 100. So the R is any mutation up to the maximum mutation that we set up there. So in this case, 5. R is going to generate a random number below 5, or up to 5, which will then be added to stat J and subtracted from stat K. And so as a result, the warrior's stats will still add up to 100, but there'll be some random variation within those stats. and that's the mutation stage. The next stage is the battle stage, where the warriors will all fight each other, um, and they'll use the process detailed earlier, where the physical, magical, and depending on who's faster, decides tiebreakers, um, and depending on their success, if they win, they're added to the gene pool, potentially, because if they win in nature, right, they have like a chance of reproducing, and so they're more likely to have offspring continuing in the gene pool. And then in this gene pool, we're going to choose some of these successful warriors, and they'll have offspring. And then these in the gene pool now will form the next generation, and they'll go back up and do this process all over again. And so in this particular problem, I'm going to stop talking about the genetic algorithm in general so much and talk about the specific results now with regards to the dueling problem. It seemed like it was weighted very heavily in favor of magic attack because the pattern of rounds, assuming you'll end the game within 3 rounds, gives magical attack a lot of importance. And defense is just sort of not quite as good as attack as a stat, and speed. It's like in Pokemon, you want enough to win speed ties, but not a ton of speed. And this might get into game theory stuff with speed. I don't know, but and there's probably other game theory stuff as well. I have no idea about, which is I'm sure all interesting. But yeah. Anyway, going back to what this algorithm produced, it seems to favor very high magic attack. For like around, I would say 50 to 70, which means that half of its distribution in all the stats is just going to magic attack, and much less to physical attack. I think the only reason they have anything in physical attack, given that you use it half as much as magic attack, is that they've also started optimizing their defenses, and putting more in magical defense because they obviously are going to use that more too. And then there are the speed values, which are actually a bit higher than I expected for some reason. I thought they would be really low. But the speed values are just sort of to beat out each other, and as a sort of like, I think I've heard it described as a dump stat, where like you don't get as much value from putting anything else in, or putting like a few more points into anything else. So you just dump it into speed because it could actually make a big difference in speed. And so that's the specifics of this problem. I submitted a warrior, but I don't know if it actually submitted. I don't know if it was a good warrior or not. But again, this is not really the game theory aspect of this particular problem, but it does have the genetic algorithm for the creation of various like generations that will follow each other and hopefully evolve into being fitter warriors.